Thank you. Let's take a look at this first example. Get right into it. What do you think we do first? We could do that. We don't have to. That would work in this case. What else could we do? Yeah, we could do that too. And whether we were doing one or the other, we'd probably end up doing this. Whoops, so I'm going to bring the 2 to the other side. So cos 2x equals root 3 over 2. And so what could I do? Does anybody know what I could do in this step? This question should look like a linear trig equation that we did Thursday. So what do you think? What if we do shift cos on both sides, right? Like doesn't this just look like cos theta equals root 3 over 2? Yes? Except instead of theta, it's 2x, but it's just a thing. What do you think? Sia, what do you think? Yeah, so we don't actually have to use a calculator, so what would it be? Pi by 6? So if theta related is pi by 6, do you agree with that? Come on, wake up, wake up. Are we okay with it? This is from last unit. This is important stuff. This part's supposed to be what we're really good at so we can focus on the harder stuff. Okay, so that would mean 2x is equal to pi by 6. Do we agree with that? And we know that there would be 2 answers in the first cycle of the graph. There would be 2 places that would give us root 3 over 2. What's the other one? Pi by 6 is 1. What's the other one? 11 pi by 6. How'd you get that? Yeah. So this is the quadrant 1 angle. Cosine's also positive in quadrant 4. So 2x would also equal 11 pi by 6. Are we good with that? But we're not looking for 2x, we're looking for x. So this should be an easy idea. Divide both sides by 2. I get x equals pi over 12. X equals 11 pi over 12. Make sense? I haven't done anything weird here. Okay? We just had to divide by 2 at the end. Don't you think? Okay, so here comes the new part. That's not really the new part. Here comes the part that's tricky about today. Let's take a look at this graphically. So I'm going to start by graphing just cos of x. Okay? And I'm going to ask, when is that equal to, so I'm going to do y equals, I think we do it like this, square root of 3 divided by 2. Whoop, divided by s, divided by 2. So that gave me a line. Do you see it? You see the line there? Okay. And so it crosses the green curve of cosine is equal to root 3 over 2 in two places. We're okay with that? But our question was, when is cos of 2x equal to root 3 over 2? Not cos x. So when I graphed it, I purposefully, but I graphed the wrong curve. So if I go and fix that by adding a 2, what's going to happen? What happened? It compressed it. What else? Emma? You're on the right track. There is something you can add on to that. Yeah, so the reason why this point is still highlighted on the right is just because of the software, but what if I carefully take a look? I mean, whoop, that one didn't work. Undo. Not going to let me get another point. Anyway, there's another one there. There's another one there. This still occurs before 2 pi, right? So from here to here is one cycle. That's where we were asked to find the solutions. So in other words, we're not done. There's 2 more solutions. This is what I think is so interesting. Like when we're solving equations, we pull ourselves out of the graphing idea, right? Often when we're learning something new, we learn it in parts. So the graphing part is separate from the solving part. But if you can use your understanding of graphs to think about the nature of this equation, we can use that to help us solve the question, think about what the solution would be like, that sort of thing. Does that make sense? So everything we've done so far is fine. I found this and I found this. I found those 2 points. Okay, this point right here is 11 pi by 12. It's just, there's pi, it's just before pi. So 11 pi over 12 is just before pi, right? So that makes sense. And this is pi over 12, so it's like those answers match what we see in the graph. So then my question to you is, how do we find the other 2 points? How do I find this point? How do I find that point? Pi minus theta related and pi plus. Would this be my theta related? Is that what you mean by theta related? Like it wouldn't be that, right? Because that's 2x, but something like that. That's good thinking. That will kind of work. Why would that work? Add another cycle, you mean, right? So instead of 2 pi, go all the way to 4 pi. So that's really interesting thinking. Thinking about, well, this is one cycle. What if I find them in like the second cycle? Like, what if I think about that? So that will work. Absolutely, yeah. Well, that'll find one of them. So like a combination of your 2 answers would find them both. What else could you do?
Can you just add pi to your existing points?
Why would that work? Can you explain why that would work?
Because it's the same cycle again, so the points would be in the same place, just on the second half.
I think that's probably the easiest way of doing it. I know that if I add a period from this point, I'll end up back on that same point. So I could just take these points and add a period, which happens to be pi, because it was cos 2x. You wouldn't always add pi. So those would all work. You could do it however you want. But I would say, yeah, let's add pi. That's gonna work in this case. If I had a question that was cos 3x or cos 4x equals, I wouldn't add pi, I would add something else, but I would still be adding like the period of the graph, and then that would find the other things. Nice. Okay, so let's do it. And so then x also equals pi plus pi over 12, which is 13 pi over 12, and x also equals pi plus 11 pi by 12, which should be 23 pi by 12. 12 pi over 12 plus 11 pi over 12, 23 pi over 12. And when we're doing any of this kind of work, solving any trig equations, if my answer is not all the way clear, because I got a lot of junk all over the place, like you might have a related angle that you solved for, and then you've got a whole bunch of x's, and we've got like x equals this, x equals this, x equals this. So it depends on how you format your answer, how neat your work is, but it's a really good idea that you may want to sort of summarize what you found. So x equals, so you'll often see this in solutions, pi by 12. And I mean, there's no rule that they have to be in order, but I'm going to do it that way because it is a little bit easier to read. There can be questions where you get a lot of answers. So trying to have some order to them can be helpful. Okay, so we got 4 solutions to that one. And the graph showed that it should meet that line at 4 points, so that within that domain, right? So that all worked. Very good. Just to go back to the graph for a minute, I don't know if some people wonder this. Probably for most of you, it's obvious, straightforward, or you get it. But you know, why does it restrict the domain on which we're looking for a solution? Like, why do all these questions always say that? Yeah, there'd be infinite solutions. So if you think about when you're solving any equation, and we'll do this year, again, we think about that as different from graphing. But any equation, I can think about it as the left side is one graph, the right side is a different graph, and the solutions are where those two graphs meet, right? That would be true for any equation, even the ones you solved back in elementary school in grade 9, 3x equals 9. You could think of those two sides as graphs. Not very helpful, but you could, right? So if we think about the two sides of this equation as graphs, it's where those two graphs meet. And so if we think about this horizontal line, it's going to meet cosine in an infinite number of places if we don't restrict the domain, right? So we always do. And you could change that restriction, like it's possible. I'm not just going to throw that at you out of nowhere, but right, for whatever reason, you may look at a different domain or something like that. Okay, let's move on to the next one. Why don't you try it? What would the first step be? Man, can you tell me how you started this question? the 3 to the other side should look like this. I'm going to do it in a different color just so it stands out since our other solution's kind of in the way. Whoops. Cosecant 2x equals 1 over 3. And then what was your next step? Nice. So 1 over sine of 2x. And I like the way you did this. Because we could skip to the next step. Like, you don't necessarily have to show this step, but for a lot of people, it might help clarify what it is we're actually doing. So that was just like a trig identity we used almost, right? We replaced cosecant with 1 over sine because that's their relationship, their reciprocal. So somebody help me out. What could I do now? What would help me understand this question better? So I can flip both sides of an equation at any point in time, right? If I have an x on bottom and I want it on top, I can just flip both sides. So sine of 2x equals 3. And then what can we conclude about this? Not possible. Okay? We talked about this briefly because Emily asked about it last week, if you remember. This is a place where I actually would totally say, and you would have to, no solution. And the reason why I would say this is different from the other one we were looking at the time is this one's done, and it doesn't have a solution. And if something doesn't have a solution, you should state that. Remember, the other one did have a solution. It came from a different place. This one, I would say, and you don't say not applicable, but I'm going to say not possible, therefore, oh, geez, no solution. So that's my answer to the entire question, right? That this question doesn't have a solution. So what if we change it a little bit, and instead of it being cosecant 2x equals 1 over 3, what happens if I get cosecant 2x equals 3? We do the same thing where we get sine of 2x, so I skip that middle step this time, equals 1/3. This one we can solve. So I want you to go ahead and try that. even if you remember doing this in the previous unit in grade 11, that kind of thing, again, it's funny how we start adding layers to it and it starts getting harder, and then we forget some of the little things that we used to know, like we forget that they apply here. So how is this question different from A? Not using the special, this was a special triangle, root 3 over 2. We recognized that. This one isn't. 1 over root 3 sometimes fools people, they think it is, but 3 isn't in there anywhere, just the square root of 3 is. So how do I solve it when it's not a special triangle? Like, what would be my next step for anybody else who might be stuck? Yeah, you use your calculator, sine inverse, right? You do shift sine 1 over 3, and that's going to equal your 2x. So if you haven't tried that, do that. Make sure I'm in radians. Does anybody want to help out with what else we do after this step? Hopefully you were able to move forward. Yeah. Could divide by 2. What else? What? Yep, that's fine to do, which gives us our actual value for x. What else in general do we have to do? Megan? So again, the last question was cosine. So we went to the 4th quadrant because it was positive, but this time we're going to go to the 2nd quadrant because that's where, because this was sine, that's where sine is positive. All that same old stuff that you've been doing for a long time now. So we're going to find that, and we're going to find that for 2x equals 2 pi, nope, not 2 pi, sorry, pi minus 0.33984, right? And then divide that by 2. That's only 2 of your answers. You got to go find the other 2. So finish that off if you haven't already. And so again, in this situation, it'll be the same thing. We just add pi to both of them. 3,115 and x. Oh, I should show that step because otherwise it kind of looks like it's coming out of nowhere. Pi plus 1.6992, which is 3.3115. You can't see that, I know. That's okay. Okay, so again, I have four final answers. 1, 2, 3, 4. Any questions about that? We're going to do one more. Yep.
You said that it's not always going to be like 2x, like sine 2x, if we're going to 2 what's another example of how?
I believe that all the questions we're asking you to do are just 2 theta. So I don't think you're actually going to have to do it. But what I was trying to say is, if you had to, if it was like cos 3 theta equals 1/2, you wouldn't add pi to find the other values. What would you add? Like this technique that we used, we were adding a period. That's why we added pi, because that was the period of the graph cos 2x. So if it was cos 3x, you'd have to figure out what the period was and add that. Does that make sense? Yeah, which would be 2 pi over 3 or whatever, or something like that, right? Like, okay, let's do one more. What do you notice about this question?
It combines a few things that we've done.
Yeah. So it's got the 2 theta in there that we've been doing today, but what else does it have? It's got the quadratic. It's got the sine squared. And so, I mean, you could have any combination. Remember how sometimes you've got sine and cosine? That was like the learning goal that you did. It had one of each. You had to switch it. You had to use an identity to switch it. So it was all in the same thing. Sometimes you have those common factoring type questions. I mean, they could all overlap, right? You could have a common factoring question with a double angle, quadratic type question with a double angle. Like, all of them are possible. That's where it starts to get very challenging. So this one, no switching necessary, everything's in sine. So in general, how do I factor this kind of, I meant to say how do I solve, I just told you how to do it. Put your pencil down and watch something that I'm going to do though. I'll just go ahead and do it. So don't write any of this down. I'm going to erase it after anyway. This is like 6 sine squared x minus sine x minus 1 equals 0. And those are the kinds that we were doing Friday and Thursday. We saw them like this. Whether or not it's factorable, we don't know yet. But this is also like, do it in another color, 6y squared minus y minus 1. Right? So that's the thing. That's actually a quadratic, and that's the thing that we want to see if it's factorable. We factor it the same way, but instead of y, it's going to be sine x. But actually, instead of sine x, it's going to be sine 2x. Okay? How can I tell the best way to start solving this question? What should I do? How do we do that? Have you done that already? Yeah. What is it? 25. So what do we conclude from that? It is factorable, therefore factorable. You don't have to show that work. You don't have to say therefore factorable. That's all for you. But if you do it on a page, like you could do it on the page and communicate it to yourself. I mean, I like to know what you're thinking. I like to know what you're doing. So if you put it down, that can help me understand better, the approach that you're taking. But it's totally for you. To me, that's like you could just do it on your calculator, and then you start by factoring, that kind of thing. Okay, so I'm going to let you again try to solve this one. There is one more question that we're going to talk about in a few minutes, but I'm going to let you, this one's a long one, and then from the worksheet the other day, finish it if you haven't already done it, but you can do question number 4 now. Those are the kinds that are double angle, okay, and there's some trickier ones in there for sure. But we will take this up